Alright guys, so we are going to start Unit 6 Day 2 by answering questions that you should have from the homework that you're about to turn in before you go to lunch, okay? So go ahead and pull out that homework. You had like simplifying, you had dividing, and the nth root of these radicals that you're simplifying. And I want to work 3 problems with you, okay? Yeah. Number 18. Let's go to 18. It's a good one. This one is on the dividing radicals. So number 18 on the dividing radicals. 4 over root 2 minus 5 root 3. Okay. The biggest thing that you should look at, secondly, guys, yes, there are answers online. Yes, unfortunately, there are some people that will copy the answers and not learn the information. Please do not be one of those people, because when we get to the quiz, it is a big, oh my gosh, I should have learned this. You can use a calculator to check. You just type it in the calculator. A lot of times you press enter, it will give you the reduced answer that you should have written, okay? But again, please, please, please make sure that you are doing the homework. It is not Pearson, it's paper homework. I do have 4 student aides that are helping grade these, so please make sure that you know that it's not for completion grade. I'm actually going to look for work and all that other good stuff. Please show enough stuff that shows that you're learning it. Alright, the most important thing on this problem to simplify is to identify that I need to get rid of these square roots in the denominator, okay? So the square roots in the denominator, I'm going to multiply by a form of 1 called this conjugate. Reason why I know that it's going to be a conjugate and not just a square root is the fact that that subtraction says there are 2 terms in the denominator. Okay, so I'm going to multiply by the conjugate. Yes?
If you do some work that we didn't do, are we allowed to add to?
Yeah, for sure. Yeah. So here we go. This is the form of 1. Root 2 plus 5 root 3 and then root 2 plus 5 root 3. Again, this is legal because it's an expression that I'm multiplying by a form of 1. Okay? And I'm identifying this subtraction symbol so that I know exactly what I need to make both of these. You with me? Can someone tell me why it's plus and not minus? Because I want to cancel out the b term. This is called a difference of squares. You should see a difference of squares down here that you know you're not going to have a b term. It's going to be a first term and a last term. No square roots left. Okay? So if I were to look at that like scratch work off to the side, this is all I'm going to be doing so that I could see. Look at this. The outside is a positive 5 root 6. The inside is a negative 5 root 6. Those will add to be 0. So there's no b term. Now, what will the first, anyone, terms give me? 2. This will give me a negative what? 75. Negative 75, okay? Because the 5's become 25, and the root 3's become 3. Okay, so you have a 2 minus, because it's a positive and a negative, 75. We good? So I get a negative 73 as my denominator. Okay? Now, simplifying radicals means we're not allowed to have square roots in the denominator, but we can in the numerator all day long. So when I distribute this, I'm going to distribute that 4 with the square roots on both of these terms, the square root of 2 and the 5 root 3. Okay? So let's go ahead and distribute here and here. Anyone? What do I get for the first one? 4 root 2. And then 20 root 3. This is definitely allowed as far as to be your final answer. Some of you may choose to write it as 2 different ones. If you do, please understand that this would make that subtraction. Okay? And then it would be 20 root 3 over 73. Both are okay. And the reason why they're okay is because I cannot reduce 4 with 73. I can't reduce 20 with 73. 73 is prime. And I cannot even add the top together because they don't have the same square root.
So I made the top terms negative, so the denominator would be positive. Is that
That's okay, yeah. So this is a big reason why a lot of people don't like this, is because of the negatives and where does it go, okay? So the negative could multiply just with the denominator, or the negative could multiply just with the numerator. If you put it, watch, this is a huge question. He's going to get points for this because it is a huge question. If I have 4 root 2 plus 20 root 3, and it's over 73, and I told you, apply the negative, there's 3 ways you could do this. You could do it like that. You could do it like this. Or you could do it like this. You with me? The first one was easiest to see. The second one that I showed you, where it was way out here, basically says it's applied to the top or the bottom. You choose. But you don't have to write it out. And this last way that I did it is it would be a negative 4 root 2 minus the 20 root 3 all over a positive 73. Any one of those variations are correct. Okay? Any questions from that problem? Yes?
Could you like simplify the 4 and the 20 like at the front? Like take out 4?
Okay. That's a really good question too. So let me, nice job, 7th period. So 100, really, really good questions already. And actually they will go with your new group. So I'll put it off to the side. Sammy's asking, could you GCF out, let's say from here, a 4 that the 20 and 4 have in common? Watch, here we go. 4 is going to be GCF'd out, and the scraps are root 2 plus 5 root 3. All over negative 73. You can, but the reason why we didn't is you would only do that if you knew that this would somehow reduce with 73. Because it doesn't, you're going to see this the rest of the year, for at least the next 2 units, we can leave the 4 in there. We don't have to GCF it out. But nice look. Yes?
So say like we could, like say it wasn't 73 and it was something like 24, we can like simplify it. And if we didn't, would we get like points on one test if we just left it like without?
So yes. So part of what you're learning in this unit, really good question, is if you don't simplify fully and you could have GCF something out to reduce and cancel it, those are points that you're losing. Yeah.
Would it be incorrect if, say, like the denominator was, like she said, 24, and you simplified the 4 and the 24, but not the 20? Would that be like incomplete simplified?
Yes. You heard what they're saying? Really, really good questions. So 4, 24, 4. Let's say that I had something like that. You with me? I could GCF a 4 from the top. Whoops. And that would be y. And then I could cancel the 4 to get it fully reduced to this. But what Emily was just asking is, what if, when you broke it up, you reduce that one, but you didn't reduce the other one? Yes, those are still points that you would lose because you're not reducing fully. Cool. Our goal is to do this GCF that Sammy was talking about so that you can ultimately reduce it so that you have that going on. Cool? Any other questions? Alright, so let's find another one. Okay? What other one do y'all want to go over from the homework? 21. Okay, so 21 on which one? Same thing? Okay, so the dividing 21. And I see, here we go, 5 plus 3 root 4 minus root 5. Okay, so 21. This is another conjugate. I'm staring at this thing and I'm trying to recreate it, but with the opposite sign. That is the conjugate. What 3 words am I thinking about right here that I just accomplished? Difference of squares. So I know that when I multiply it, what is the first term going to be? 16. The second one will be minus 5. So this will give me an 11 on the bottom. And now I just have to worry about distributing this top, because square roots are allowed in the numerator. Okay? Guys, what's the first one? 4 root 5. What's the outside? Plus 5. What's the inside? Plus 12. And what's the last? Plus 3 root 5. Can I add those two together? Yeah, because they're the same root. Okay? And what would I get? 7 root 5 plus 17. Now let's go back to what Sammy was saying last time. Your goal from here is to identify that you have two islands, if you will, two monomial terms up top. You have one on the bottom. Can you pull something out GCF that you will be able to cancel with this 11? Yes or no? No. So then you know right there it's good enough. You with me? Questions? Like, let me show you this. What if this was 17? Some of you might say, well, I could reduce the second one, but I can't reduce the first one. If you left it like this, it would still be full credit. Okay? Because you don't have to say, man, I was supposed to do that. No, we're not going for that kind of things. If they're GCF on both, then yes, reduce them. But if you were to reduce, you see what I'm saying? If you didn't do this and you wrote this, you would still get full credit. That's okay. Yes?
In our polynomial student, we always ordered everything from like greatest to least.
Okay.
Do radicals have that? Or does
So
it matter?
it doesn't matter. The only thing that I'll say is this. This is the order. This is a good question. The order that I want you to simplify stuff is put the constants first, basically the numbers, and then put the alphabet next in alphabetical order. However it reduces, just put the alphabet in alphabetical order and you're good. Cool? What else? One more? Okay, then we will leave it at that.